If we think of mass as the amount of matter in an object and volume as the amount of space an object takes up, then density is the relationship between mass and volume. It is the amount of matter that can be packed into a specific space. The density of a material is its mass per unit volume, and we want to include units. All right, so now we're going to take what we've learned about volume and use that to find density. So density is a ratio of the mass, people, things to volume area. Given the density in one of the two quantities in the ratio, you can solve for the other quantity in the ratio. All right, so you follow along and take notes as it's in your note packet. And you can add this to the notes. All right, so some common units for density for solids: grams per cubic centimeter, or if it's something large, kilograms per meter cubed. For liquids, we can do grams per milliliter or kilograms per liter. And just so you know, 1 cubic centimeter is 1 milliliter. 1,000 cubic centimeters is 1 liter. So sometimes we have a unit that's not so easy to work with. It maybe not happen in this class, but in future classes. And you have a liter, and it'd be a lot nicer to have something in cubic centimeters. No problem. You can change liters to cubic centimeters, and it's 1,000 cubic centimeters. So not so much for your work in this lesson, but the notes over here will be really helpful later on. And there we go. So the formula states that density of an object is the ratio of its mass to its volume. If two objects have the same volume but different masses, the object with the greater mass will be denser. You can also think about density of an area of land, such as a city. In this case, you would look at the ratio of the number of people to the area of the land. And it doesn't have to just be land, it could be in a room, right? That's space. And so a city will have a higher population density than land in the country because more people live in each square mile of a city than live in each square mile out in the country. Right? So whether it's density or population density, it's going to be the mass. And if it's population density, you can think of mass as number of people and over the unit of measure. For density, it'll be volume. For population density, it'll be area of land. Because you don't really count volume of land, right? Because nobody's living up in the sky. Right? You live on the ground. Right? All right, so let's try the first one. A cube of metal has a mass of 1,350 grams and displaces 540 milliliters of water when immersed. Right? So displacing liquid is the same as volume because some things it's hard to find the volume of. Right? So when the cube, if we had have the side measures, we could find the volume of the cube. But what if you had something that was irregularly shaped? Right? Then it's really hard to find the volume. But another way we can find volume is by taking our object, putting in water, and having that water be in something with measurements on, in a graduated cylinder, for example, and seeing how much liquid it displaces. So whenever you see displacing of liquid, that's volume. All right, so you can put that in your notes. And let's calculate out the density here. Right? So, and we will reduce this. Density is usually given as a decimal number. We won't keep it as a fraction. We'll approximate with a decimal, and we'll take it out to 4 or 5 decimal places. So the density of the cube equals the mass, and the mass is 1,350 grams, and the volume is 540 milliliters, right? And so not only will we reduce this, we'll also include the units of measure. All right, so the density of the cube is going to be 1,350 grams divided by 540 milliliters. right? And so that is, let me grab a calculator. 1350 divided by 540. And so that, oh, that's a nice number, 2.5. And so now this is a solid. Let's see what the units of measure we had on the other page was. So this is grams per, oops, one more page. Grams per, and we had grams per milliliter. All right, usually that's a liquid. We're talking about something liquid. You can change, where you have milliliter, you can change that to cubic centimeters. So back here, one more, and there we go. So back here where we have we can list that as 2.5 gram, too far, too far, back one more. Okay. Here we can list that as 2.5 grams per milliliter, but since it's a solid, you could also list that as we can replace milliliters with cubic centimeters. So, or we can list it as 2.5 grams per centimeter cube. All right, either is okay with me. All right, let's try another one. All right, so if you've got the mass and the volume, all right, it's pretty easy to find the density. All right, so 216 grams of salt has a volume of 100 centimeters. That's centimeters cubed. Some reason the cube didn't end up being an exponent, but it's supposed to be. What's the density of the salt? All right, so density of the salt. All right, we take the mass. All right, so the mass is 216 grams. And the volume is 100 centimeters cubed. So that would be 216 grams divided by 100 centimeters cubed. All right, so that's going to be, this is an easy one, I don't even need a calculator, 2.16 grams per centimeter cubed. All right, so always have to make sure you have the units of measure. Right, and it'll be your mass unit of measure divided by, or per, your volume unit of measure. Although feel free to change milliliters to cubic centimeters if we're talking about a solid. A ball has a mass of 46.9 grams, right? So that's mass. And a volume of 40.5 centimeters cubed. What's the density of the ball? Right, so density of the ball is 46.9 grams divided by 40.5 centimeters cubed. So the density of the ball, actually I'll just put equals. And I will use a calculator now. 46.9 divided by 40.5. It's getting dark in here. I can't see the numbers in the calculator as well. And that was 1.1580. Number came after the 0 was a 2, so 1.1580. And that is grams per centimeter cubed. Before I turn the page, which one, I'm going to ask you, which one has the greater density? Is it the salt or the ball? Right, so if you're trying to figure out which has the greater density, which number is larger? Right, so when you just know mass and volume, you can't compare it. But once you change to density, you can see that the density of the salt is greater than the density of the ball, because, here's my symbol for because, right? 2.16 is greater than 1.1580, right? So whoever has the greater density, right, whichever has the greater number has the greater density. All right, let's try another one. All right, so gold has a density of 19.32 grams per cubic centimeter. Right? And our density is mass over volume. We're going to rewrite the density equation for each of the following. All right, so here we're not going to find the mass or the volume because we're only given one piece of information. But we're going to rewrite them so we could solve for mass or for volume if we had the other. So you'll include this in your notes as well as the steps. All right, so to solve for mass, you'll write the density equation and then multiply both sides by volume. Right? So let's set up the equation. Remember that density is mass over volume. Right? So mass over volume. And we're given the density here. It's 19.32 grams per centimeter cubed. Right? And so now if we wanted to find the mass, we would multiply both sides by the volume. So we have volume times mass over volume equals 19.32. Now, one of these units of measure would cancel. And of course, it's the centimeters cubed, right? Because centimeters cubed, that is a unit of measure for volume. It's not a unit of measure for mass. All right, so if we multiply both sides by volume, that cancels out. So mass is going to be the same for our gold example here as 19.32. The centimeters would cancel out, but grams times, or volume times, and then in terms of grams. So 19.32 times the volume, and the unit of measure would be in grams. That's what I'm trying to say. All right, so here's how, if we're looking for mass and we're given density and volume, how we'll find it. All right, you can put this part in your notes too, to solve for volume. So we're going to write the density equation again. Right, so mass divided by volume equals, in this case we know it's 19.32 grams per centimeters cubed. All right, so we want to get volume all by itself, right? But we can't do anything until we get it out of the denominator. So just like before, we're going to multiply both sides by volume. Now we don't know what the volume is, so it won't cancel out the centimeters cubed yet. So, but it will cancel out over here. So this will give us mass equals 19.32 grams per centimeters cubed times volume. But we want volume by itself. So now we're going to divide both sides by density. And then, so we divide that side and this side by 19.32 grams per centimeters cubed. All right, so the volume is going to be left all by itself, right? So the 19.32 grams per centimeters cubed will cancel. And so we'll be left with volume equals mass divided by 19.32. right? And the grams will cancel out, right? Because mass is already in terms of grams, and our units of measure will be centimeters cubed, right? So if you have the density and volume and you want to find the mass, if you multiply the density times the volume, you get the mass. If you have the density and the mass and you want to find the volume is the mass divided by the density. All right, so if you need to, you can pause this to put this part in your notes. It's probably the most amount of notes in the entire lesson. All right, and I might stop here or I might do one more problem. Let's see what the next problem is. And then I'll know. Let's solve for the next problem. All right, so here, actually, let's see what page I'm on. 38. Yeah, we'll do one more. All right, so a block of wood has a length of 10.2 centimeters. So a block of wood, this is a rectangular prism. Now you can see why I reviewed volume first. Right? So we need to find the volume. And if you remember, the volume is equal to the area of the base times the height of the prism. And the area of the base is the little b and little h, the base and height of the base. So let's just draw the picture out here. Right? And I don't promise this to be beautiful. So until we find the volume of this, we can't find the density, right? Because we need to, volume is part of this equation. All right, there we go. All right, so we're told that the length is 10.2 centimeters. The width is 6 centimeters. Now, length and width, base and height, they're exactly the same. And the height of the 4.1 is the height of the prism. Right? Not centimeters. Right? So height is the distance between the bases. Right? That's sometimes why length and width are used, not to confuse yourself with base and height for the rectangle base. But length and width are never used for triangles. I don't know why. All right, so the area of the base is going to be 10.2 times 6. So the base is 61.2. Let me just check that. Yep. The height of the prism is 4.1 centimeters, and this is centimeters squared. So that makes the volume equal to the area of the base, which is 61.2, times the height, which is 4.1. So the volume is 250.92. Now we need the units of measure. That is in centimeters cubed. Now to find, so we had to do the work to find the volume so that we could find the density, because density is the mass times the volume. So the density, we're given the mass, right? So mass is 179 grams. So that would be 179 divided by 250.92. And we should have the right units. So the 179 is grams, and this is centimeters cubed. So that means the density is 179 divided by, that is 0.71337. Maybe I should turn the lights on here. 0.71337, and the units is grams per centimeters cubed. Just the same way as they appear. The mass unit of measure first, and then the volume unit of measure. All right, so there we go. This one just a little more involved because we had to find the volume of the prism first, the block of wood. All right. And I think this one is a good place for us to stop at 20 minutes. All right, so we'll continue with density. And the next problem we're going to be solving for mass. All right, so see you in the next video. Bye for now.